Okay, so we're on page 16. And this whole section kind of starts pulling together a lot of the ideas from the first two sections. Sines, cosines, tangents, and those things. Angles in degrees and radians. We know how to find the sine, cosine, and tangent of any angle in a right triangle. But now we need to deal with what if we have angles bigger than 90 degrees that would make a right triangle, or what if we have negative angles, and all those things. How do we find the sine, cosine, tangent of those? We need another definition for the sine, the cosine, and the tangent. First of all, though, I'm going to draw a terminal ray of an angle over here. I'm going to deal with this angle, which I'm going to call theta. And I'm going to say that my terminal ray passes through the point x, comma, y. I've got an angle. It's an angle in quadrant 1, but we'll see in a moment that we can use what we're starting now to deal with angles in any quadrant. And that terminal ray goes through the points x, comma, y. Well, I could make a right triangle over here, because theta is a small enough angle. I've got my right triangle like that. If the coordinates of this point are x, comma, y, what's this distance? X, right? If my x coordinate is x, I have to move over x. The base of my triangle is x. Right?
Yes.
Thank you. What's the height of the triangle? Y. As for the other side, the hypotenuse, well, first of all, I'm going to call it r, as in the radius, because this is like the radius of something that's spinning around. But I have a way I can calculate that. How? Pythagorean theorem. I think all we need to do is x squared plus y squared equals r squared. Or we can say that r is just the square root of x squared plus y squared. The reason for this. This triangle is perfectly good. I can do opposite, adjacent, hypotenuse, all those things to find my sine, cosine, and tangent. When I have an angle bigger than 90, though, I can't draw a triangle. That's not going to work. I need to use a definition that uses my x-coordinate, my y-coordinate, and my radius. Here's what I mean by this. The sine of theta. We know that sine is normally opposite over hypotenuse. Over here for theta, what is the opposite? Y. What's the hypotenuse? My new definition that I'm going to be able to use for any angle everywhere is my y-coordinate over the radius. Y over r. Cosine is normally adjacent over hypotenuse. Well, what's the adjacent here? X. The hypotenuse is r, so x over r. I want to see if you can come up with a tangent formula. Y over x. Moving forward, we are going to use, did you just figure something out? Actually, yeah, the tangent will give us the slope. The tangent, yes. I don't want to say more right now, but yes, absolutely. Moving forward today, we're going to be using these definitions rather than opposite, adjacent, hypotenuse, and those things. In letter A, I would like to find the sine, cosine, and tangent of the angle whose terminal ray goes through this point. And I think just to get me started, I should probably draw something out. What quadrant is 5, negative 12 in? I'm thinking quadrant 4. Go over 5, go down 12. I'm not going to make this super exact, but I'm going to say that my terminal ray is over here. And if I have a positive angle, I'm dealing with this angle over there, which is way too big to be in a right triangle. However, to find the sine, the cosine, and the tangent, all I need is my x-coordinate. Do I know that? Yeah. My y-coordinate, do I know that? Negative 12. And my radius, which I don't know. Why? Yeah, and there's a formula that I could use to figure this out. That whole r equals that square root of x squared plus y squared. In this case, it's a nice number, but if we didn't just know that, we can go use our formula that says the square root of 5 squared plus negative 12 squared, which is 25, plus 144, which is the square root of 169, which is 13. No, not for something like that, but for usually we're going to need to use Pythagorean theorem, so I will need to see that. We have all the information we need now to find the sine, cosine, the tangent of this angle that's bigger than 270 degrees. The sine of theta is defined as the y-coordinate over the radius. Y-coordinate is what? Negative 12. My sine of theta is negative 12 over 13. The cosine of theta is defined as the x-coordinate over the radius. So what's that going to look like? 5 over 13. The tangent of theta is the y over the x. Negative 12 over 5. I didn't draw a right triangle because I couldn't draw a right triangle with an angle that's that big, but I can still find the sine, cosine, tangent not using opposite adjacent hypotenuse, but using this x, y, r stuff. I'd like you in letter B to draw it, although I feel like after B maybe we'll skip the whole drawing part because we don't really need the picture. And I'd like you to figure out what your radius is, what your r will be. What quadrant? 3. Left, down, that puts us in 3. So I'm dealing with this angle bigger than 180 degrees. Do you have the r? What is it? Square root of 37. Root 1 plus 36, square root of 37. I think you have everything you need to find your sine, cosine, and tangent. We've got the x, we've got the y, we found our r. Go find your sine, cosine, and tangent, and when you're done, simplify them fully. No. After this one, I think we'll just go straight to our formulas. We'll see for the next couple of ideas, though, in the section, we will absolutely need the picture for some other things. But for these, no, we're not going to need that. Y over r, x over r, y over x. Brittany, do you have the sine of theta? Yeah, what did you start from? Perfect. Y over r, but not good enough. Go rationalize. So times root 37 over root 37. Yep, so negative 6 root 37 over 37. Okay. Giovanna, how about the cosine? And then what are you going to do to that? Perfect. Negative root 37 over 37. Tyler, what about the tangent? 6. You're going to do just negative 6 over negative 1, but don't leave that. Tell me 6 for the final answer. Do you see how this is working? Nod your head if you're with me so far. Again, if some people have asked, no, we don't need the picture, so if you want to go straight to your x, y, and calculate your r and then go, that would be okay. I want you to try C and D right now on the next page. C and D. And there's no reason you should have all that blank space there. It won't take the whole page. I think even though there's a root in C, the radius should actually be good. Silas, do you have the sign of theta for letter C? Y coordinate over the radius, root 7 over 4. I like it. Alyssa, what about the cosine? I need the x coordinate, negative 3 over the radius, 4. Or you could just say negative up front, 3/4. Either way would be okay. Manya, what about the tangent? One more time? Good. Root 7 over negative 3. And if you want to move the negative out front, which you don't have to, but if you wanted to, just negative root 7 over 3. But we should have something like that. Kiara, what do you have for D for the sine of theta?
5 root 61 over 61.
Good. It should have been 5 over root 61, but then you're going to rationalize your denominator and say 5 root 61 over 61. Paige, what about the cosine of theta?
6 root 61 over 61.
Yep, it was 6 over root 61. So 6 root 61 over 61. And Mina, what about the tangent of theta? How are we doing with this? Not terrible yet? Okay, so this was the first of 3 things. We can now find sines, cosines, and tangents of any angle if we just know the coordinates of, like, a point on the terminal ray. Once we have our x and y and can find the r, we're good. Next thing we have to deal with. Finding trig values using the unit circle and trig identity. That's not the right title. I'm telling you one trig thing. I'm telling you that the sine of our angle is 4/5. I want you to find the cosine. I want you to find the tangent. I'll define that thing on the top in a little bit. The first thing we have to do, though, is we have to draw our angle. Okay? I need to draw a ray for the terminal side of our angle in the appropriate quadrant. Let's just write that down, then we'll figure out what that's actually saying. We are going to draw a ray in the appropriate quadrant for theta.
This is what you have to draw.
We are going to have to, yes. Let me get through the whole thing, then I think it'll become clear. How am I going to figure out what quadrant I should draw theta in, though? Is there any part of the problem I haven't actually done anything with? The what? In these problems, I'm going to give you an inequality for theta. I'm telling you theta is between pi over 2 and pi. What does that mean? That greater than 90 degrees, less than 180. That's the whole point of this. I am telling you it is an angle in quadrant 2. Is that a hand, Alyssa? Okay, so we know from our unit circle that this is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. I'm telling you I want an angle between pi over 2 and pi. That means our angle is a quadrant 2 angle. That's the first step. And I'm always going to have to give you some sort of inequality to tell you what quadrant we're in. I'm not going to say quadrant 2. I'm going to say either between pi over 2 and pi, or between 180, between 90 and 180, or something like that. Next, we are going to use this terminal ray to create a triangle with the x-axis. Create a triangle with the x-axis. And I'm not going to finish that just yet. I'm going to make a right triangle over here. Create a triangle with the x-axis, and I haven't finished that thought yet because I need to define something else first. Is the angle I want to find the cosine and tangent of this angle inside the triangle?
Yeah. No.
No, I want to deal with theta. Where is theta? It's this big thing over here. But I'm going to have to do something with this angle inside the triangle. I'm going to give a name to this angle, and we're going to call this a reference angle. So we're going to go to the top of the page. A reference angle is an acute angle between the terminal ray and the x-axis. A reference angle is the acute angle between the terminal ray and the x-axis. A reference angle is an acute angle between the terminal ray and the x-axis. Back to our problem, I'm going to create a triangle with the x-axis, and I'm going to say shade in the reference angle. I'm going to shade in the reference angle. Which is the angle between my terminal ray and the x-axis, which means I'm talking about this thing over here. I don't really want to call it theta, because theta is that angle starting over here and ending there that's bigger than 90. But it's another angle that's going to be important for dealing with these problems. Step 3. I told you that the sine of our angle was 4/5. I'm going to use SOHCAHTOA and the reference angle to fill in all the sides. Label the sides using SOHCAHTOA and find the missing side. Telling you that the sine is 4/5. I'm going to label my sides based on the reference angle, and then I'll just find the missing side. So, sine. What is sine? Opposite, hypotenuse, adjacent. Opposite over hypotenuse. I know that my opposite's 4. I know that my hypotenuse is 5. What's the missing side? 3. Who just said wait? Can't hear you. It's a triangle, so this is going to be positive 3. Hold on to that for like 10 more seconds. That's what step 4 is going to take care of for us. Okay, didn't I say that would be? Step 4. There are 5 steps total with this. To find the cosine of the tangent, though, I want to do that of this angle over here. I can't really use opposite, adjacent, hypotenuse. I need to use my whole x, y, r thing. So what I need to do is I need to find the x, y coordinates of the point on the ray, paying very close attention to the signs, the S-I-G-N-S, the positive, the negative part of that. I need to find the x, y coordinates of the point on the ray, paying close attention to the signs. And that's a big deal, so I'm going to put a box around that and maybe even a few stars. We're going to find the x, y coordinates of the point on the ray, paying very close attention to the sides.
Is that like the main point?
That's why we're drawing it, so we can kind of see, do I want something positive or something negative? That's the point. So, my x coordinates. What's the x coordinate of this point going to be? It's not 3, though. -3 because we're moving left to get there. This is the important part. What about the y coordinate? Positive or negative? We are going up to get there, so that is +4. But if we draw this thing out and can look at it, going left would make something negative. Going down would make something negative. I'm practically there. Step 5. And once we start these, it will not take this long. It's just taking so long because we're writing all these steps here. Step 5, we're going to say find the remaining trig values using x, y, and r. Find the trig values using x, y, and r. I just figured out my x-coordinate and my y-coordinate. X-coordinate's -3, y-coordinate's 4. How can I get r? It's 5. R is just the hypotenuse or the radius of that thing. We've got our r. We've got everything we need. I want to find the cosine of theta. What's the definition of cosine? Don't tell me adjacent over hypotenuse. X over r. So what is that here? -3 over 5. Do you see why I'm saying negative 3, Josh?
Yeah.
Tangent of theta. Y over x. What's that going to be? 4 over negative 3. You could also, if you wanted to, just say negative 4/3. That would also work. There's a lot that goes into these. And really the issue is this is all about attention to the detail. Are we in the right quadrant? Are we getting the right signs?
Is the radius always positive?
Yes, because that is truly a distance. And x and y, that's just based on what quadrant we're in. The next two examples, I want to work through those together before I give you a couple to try on your own. So let's take a look at number 19 on the next page. Before I do that, though, is anyone still writing things down? Yep. So, are you okay with how I drew my triangle 3, 4? Okay, I need coordinates now at this point. Well, to get to this point, I need to move left 3. That's why it's negative. And the only way you're going to see that is from the drawing. Page 19. I need to draw this angle. What quadrant will I draw it in? Why? Between 180 and 270. Okay, so here's the terminal ray of my angle. There's theta. We're going to make a right triangle. With the x-axis or the y-axis? Why? That's what the directions say. It always has to be with the x-axis. So I'm going to do a right triangle over here. And I'm going to go shade in my reference angle. This one over there. I'm telling you that the cosine is negative 6/7. Ignore the negative. We'll deal with the positives, negatives later. What side am I going to label 6? Adjacent. What side am I going to label 7? Take a moment and find the missing side and then stop. How about root 13? No? Yeah, but not for the length of the side. I totally get what you're saying, but no, you're not wrong, but I'm going to go with just root 13 for now. Can you make your triangle like that? Are you okay with that part? I need coordinates. Is my x-coordinate 6 or negative 6? Why? Not down. We're going left to get there. Is your y-coordinate root 13 or negative root 13? Why is it negative? Going down to get there. But how are we going to know the signs? We're just going to look at where it is drawn. If you're going left or going down, that thing is negative. We've got our x, negative 6. We've got our y, negative root 13. What's the r?
7.
Always positive. Go find your sine, cosine, and tangent. And just for good measure, I'll stick those over here. We will eventually need to know these new definitions of sines, cosines, and tangents. R is the hypotenuse, the radius. It's always going to be something positive. X and Y are coordinates, but radius truly is a distance. Eric, what do you have for the sine of theta?
313.
I'm not crazy about that for sine. I think sine should be the y over the r. I think you might have done y over x. So what would it be if it's y over r? Negative root 13 over 7. And Eric did give us the tangent of theta, the y over the x, so negative root 13 over negative 6. But we are going to simplify that down to positive root 13 over 6. Are you a little bit with me? At least a little bit. I'd like you to draw the terminal ray for the next example. Shay, what quadrant? 4. Because I know this is 3 pi over 2. I know this is 2 pi. So I think we're ending up over there. So we've got a really big angle like this. Going to make my right triangle with the x-axis or the y-axis. Always the x-axis. And I'm going to shade in my reference angle. This one over here. What do I know? What sides? Opposite, adjacent, hypotenuse. What do I know? Adjacent's what? Hypotenuse is what? Take a moment, find the missing side. Then after this, I'll have you guys do a couple on your own. To do x squared plus 1 squared equals this. Maybe root 35? What's the x coordinate? 1. What's the y-coordinate? Negative root 35. What's the radius? Finish this. We've got the x. We've got the y. R is 6. Sine of theta should be negative root 35 over 6. Tangent should be negative root 35. I'm going to need to see a bit of work in the homework with these problems. I'm going to need to see for these, the picture drawn out, you finding the missing side, you labeling coordinates, paying attention to is the thing positive or is it negative, and then going with the x, y, r definitions and things like that. How are we doing with this?
It's not that
It's not that bad? Does Yasmin speak for the rest of you? You're with me enough? Okay, so I'm going to stop this here. No, I'm going to